Okay, here we go, number 12. Here we go, number 12. A uniform meter stick has a mass of 80 grams. A mass of 200 grams is hung from one end, and a mass of 300 grams is hung from the other. Where should Mr. Hecker place a fulcrum to get the meter stick to balance? So let's draw this. Here is our meter stick. The problem tells us that we hang 200 grams from one side. 200 grams is the same as 0.2 kilograms. What should I do with that 0.2 kilograms? Times it by 9.8. So you get 1.96 newtons. I am going to call that force number A. Over here we got 300 grams. So 300 is 0.3 times 9.8 is 2.94 newtons. I'm going to call that force number B. And it tells us the meter stick, it says it's uniform. Why is the word uniform important? Because it means the center of mass is at the geometric center, i.e. smack dab in the middle. So 80 grams is 0.08 times 9.8 is 0.784 newtons. I'm going to call that force, do we want to use G for gravity or M for meter stick? M. I heard somebody say M, so we're going to go with M. All right, are there any other forces? The fulcrum. All right, and the question is, where does the fulcrum go? And the answer is, I don't know, because I haven't figured it out yet. So let's just do this. Force of fulcrum. Where? All right. Let's see, I feel like I haven't labeled any distances. How long is this stick? Doesn't tell us, does it? Oh, it's a meter stick. Oh, it's probably 1 meter long. That feels useful. So that means that this distance here is 0.5 metries, and this distance here is also 0.5 meters. Everybody good? What's the first thing I should do? What should we do? We've only got one unknown force, right? The fulcrum. Anytime you only have one unknown force, find it. Our net force has got to be 0. So that means force number A plus force number meter stick plus force number B plus force number fulcrum all has to add up to 0. So my net force is 0. Force A is actually negative 1.96. Force of meter stick is negative 0.84. Force of B is negative 2.94 plus the force of the fulcrum. So add, subtract, solve. Force of the fulcrum ends up being 4.9. So what, 5.684, is that right? Yes, Sabby.
So are all those forces negative because they're going down?
That is correct.
When it's for like the net force part of it, doesn't mean that like they'd be negative when you're adding up the net force, right?
Yes. Did everybody just hear that? Say that again louder, because it's super duper important, and I see people get it mixed up every once in a while.
When you're finding the net force, all of those forces are negative, but when you're going
Why are they negative?
Because they're all pulling down.
Down, and down corresponds to negative force.
Right, but when you're calculating the net torque, then those forces may or may not.
Correct. Depending on where you choose your pivot point.
Okay.
Good?
Yeah.
So when you're doing the forces, that doesn't correlate with your pivot point. Pivot point is with the torque.
Correct. Yep. Everybody good? All right, so now I know the force of the fulcrum, so now we just need to figure out where it goes. Good? So now we need to choose a pivot point and solve for the distance. I think ordinarily, honestly, if I was solving this, I would ordinarily pick my pivot point on the left. But just to emphasize what Abby was saying, let's pick the pivot point down at this end.
Did you pick the pivot point as like the center of mass as well?
Sure. So here's my only concern. So you can pick the pivot point literally anywhere you want at this point.
Right, I got it.
Okay? My strong recommendation is, suppose we pick it here. Okay?
That's what I did that's what I did.
That's fine. So do it, and then suppose you find out, I don't know what the answer is off the top of my head, so I'm just going to make up a garbage number. Okay? So suppose you pick your pivot point here, and you discover that D is 0.1 meters.
Oh, away from one.
which way, right? Is it 0.1 meters this way or 0.1 meters that way?
Oh, I never, yeah, that's why I had.
And so you can figure it out based on your torque, whether your torque is positive or negative.
Okay, I see what you're saying.
But I think if you pick it at the end, then you just know, well, if it,
Has
you know,
to be to the left.
it has to be to the left because it can't be to the right.
I get it, okay.
Follow?
Yeah.
So it's not wrong to do it the other way, I just think it's harder.
Yeah, I see.
Everybody good? Fantastico questions. So let's calculate the net torque around point P. So I'm calculating right now the net torque around point P. That's what this little P is here for, just so that you know where I chose my pivot point. All right, so that should equal the torque from force B plus the torque from the meter stick plus the torque from force A plus the torque from the fulcrum. So let's see, the net torque should be 0. The torque from B is the force of B 2.94 times 0, because that's where I chose my pivot point. Torque from the meter stick is 0.784 times, from here to here is 0.5. Plus the torque from A is 1.96 times 1. Plus the torque from the fulcrum is 5.684 times D. Cool? All right, let's check our signs. So, let's see. So 0 is 0. 0.784 times 0.5. That looks like it's going to be positive torque, right? Because it's counterclockwise, right?
How'd you figure that out?
Sorry?
How'd you figure that out?
So you need to think about your meter stick
Okay.
pivoted down here, right? So like hold your pen there and push down at the point of application of the force.
Okay, so it'd be positive.
Does that make sense? Because it's going to make it spin. That's, do we agree? That's counterclockwise, right? Yeah, that's counterclockwise. So that means it's got to be positive for that one. How about the 1.96?
That would also be.
That would also be positive. And then the last one, we don't know. Okay? So notice this is exactly what Abby was just talking about. This force here is negative, but the corresponding torque is positive. Just because of where I chose my pivot point. Follow? All right, so if you solve this, you end up getting 5.684D equals negative 1.362 or something like that. Don't quote me on that. I did that in my head. I don't think it's right, but it's somewhere in that neighborhood. Oh, no, it's not anywhere near that neighborhood. I'm sorry. How about 2.3 something or other?
2.35.
2.35? Exactly?
I think it's 2.352. So.
Ah, all right. Thank you.
Yeah.
Okay, but, so notice it's negative, right? That does not necessarily mean the distance is negative. It means the torque provided by that force has to be negative. Okay, so anyway, so you solve this, and you get, what does it turn out to? If you do it from that side? Divide both sides by 5.6, and you're going to get 2 point something, I hope.
0.41.
Oh, I divided wrong. Yeah, 0.41, thank you. Meters, so that means 0.41 meters from my chosen pivot point. And it's got to be to the left, A, because otherwise it wouldn't be on the stick. B, that's the only way it could produce clockwise torque. Alex?
So it's negative in terms of the middle of the stick, not where the pivot point is from, because from the pivot point, it would still produce, it's pushing up before.
Pushing up. Yeah. So your left and up makes clockwise.